Welcome to the class. Telugu Academy textbook. Some of the important questions in linear differential equation. Solve x plus y plus 1 into dy by dx is equal to 1. Now dy by dx is equal to 1 by x plus y plus 1. This is not a non-homogeneous equation. So then how to solve this one? This one should be converted into a linear equation. We can't solve directly with dy by dx. Then better you write like dx by dy. Dx by dy is equal to x plus y plus 1. Now dx by dy minus x is equal to y plus 1. Now this is of the form dx by dy plus px is equal to q, where p and q are functions in x. Here is x and here is x. These two terms in terms of y. So no problem. Now here p is equal to minus 1 and q is equal to y plus 1. Then integrating factor, I of integrating factor is equal to p dy, that is e power minus y into dy. E power minus y e power minus y. Now multiply the dE with integrating factor. We have e power minus y into dx by dy minus x is equal to y plus 1 into e power minus y. On integrating, left hand side, that is x into e to the power of minus y, and right hand side we can, by using first, this is first function, this one is second function. Now y plus 1 into first function into integral of second function minus integral of derivative of first function 1 integral of second function minus of e power minus y dy, that is x into e power minus y is equal to minus of e power minus y into y plus 1 minus e power minus y plus a constant c. Now you divide with e power minus y, then you will have x is equal to, when we are dividing with e power minus y, you will get minus of y plus 1 minus 1 plus c by e power minus y, that is c into e power y. Now this is x plus y plus 2, minus 1 minus 1 minus 2, that is c into e to the power of y. So this is the solution of this linear differential equation. And we can solve this differential equation, the same problem we can solve it very easily, I will say, in the alternate method for this question. You see here, this is the question. We can solve in another model. That is dy by dx is equal to 1 by x plus y plus 1. You can do the same in terms of variable separable type. That is, let x plus y plus 1 is equal to t. Now differentiate with respect to x. That is 1 plus dy by dx is equal to dt by dx. Now dy by dx is equal to dt by dx minus 1 is equal to 1 by t. dt by dx is equal to 1 by t plus 1, that is 1 plus t by t. Now it becomes variable separable type. So all t terms goes to dt, that is t by 1 plus t dt is equal to dx. Then integration. How to do this integration? Just you add 1 and subtract 1, that is equal to x plus c, that is 1 minus 1 by 1 plus t dt is equal to x plus c, that is t minus log of 1 plus t is equal to x plus c. Now t is nothing but x plus y plus 1 minus log of 1 plus t means x plus y plus 1 is equal to x plus c. So x will be cancelled. Now y plus 1 minus log of x plus y plus 2 is equal to c. You can simplify it. That is log of x plus y plus 2 is equal to c y plus 1 minus c. Now base is e, x plus y plus 2 is equal to e to the power of y plus 1 minus c. That is e power y into e power 1 minus c. This is also a constant. We can write k. So k into e power y. This is the simplest method to find the solution of this differential equation. Next, one more question, that is in Roman 3. Roman 3, this question is fourth question, the last exercise. Now one more question. These are the typical questions in the last exercise, differential equation. Solve dy by dx into x square y cube plus xy is equal to 1. How to solve this differential equation? First you find dy by dx. dy by dx is equal to 1 by x square y cube plus xy. We can't do with dy by dx. Then you change this one as dx by dy. That is equal to x square y cube plus xy. That is dx by dy minus x square y cube minus xy is equal to x square y cube. Now you divide with x square. Divide with x square. Then what happens here? 1 by x square into dx by dy minus 1 by divided with x square, you will get minus 1 by x into y is equal to y cube. Of course, this is also not in the form of directly linear differential equation. Now, you see the derivative of minus 1 by x is 1 by x square. Now, put minus 1 by x is equal to some t. Now, differentiate with respect to y. Differentiate with respect to y. Then what is the derivative of minus 1 by x? 1 by x square into the derivative of x is dx by dy is equal to t derivative with respect to y dt by dy. Now you can replace 1 by x square into dx by dy as dt by dy minus this minus of 1 by x is equal to t. So that is t into y is equal to y cube. You see here this term, this differential equation now we can express into linear differential equation. Here is t and t. So these two terms of in terms of y. Now it is a linear differential equation. Now what about the integrating factor? Now the integrating factor is equal to e to the power of y dy. That is e to the power of y square by 2. This is the integrating factor. Next step, multiply the given dE with the integrating factor on both the sides. Then e to the power of y square by 2 of dt by dy plus ty is equal to integrating factor into on the right hand side, that is y cube. Now integrate with respect to y. It is one of the important questions. You see on the left hand side we have t into e to the power of y square by 2. Then what about this integration? You see here y square by 2 y cube. Now you can write this one as y square by 2 y square into y dy. Y cube can be expressed as y square into y. Then put y square by 2 is equal to t. Now y square by 2 is equal to some k. That implies y square is equal to 2k. 2y dy is equal to 2 dk. 2 gets cancelled. Now this equation reduces to t into e to the power of y square by 2 is equal to integral of y square by 2 as k e to the power of k y square. What about y square? 2k. That is 2k. and y dy is equal to dk. Now you can do with by parts, by using by parts. What about t? T is nothing but minus 1 by x. So minus 1 by x into e power y square by 2 is equal to 2 of, this integration is e power k into k minus 1. By using by parts you will get the answer. So that is minus 1 by x into e to the power of y square by 2, 2 into e to the power of k means y square by 2 of y square by 2 minus 1 plus a constant c. Here also you can write c. Now you can simplify total dividing with e power y square by 2, that is minus 1 by x is equal to 2 of y square by 2 minus 1 plus c by e to the power of minus y, e to the power of y square by 2. Now it is minus 1 by x is equal to y square minus 2 plus c into e to the power of minus y square by 2. You can simplify the answer. So this is the process to find the solution of this differential equation. Next, the same model, okay, solve. And 10th question in the exercise, dy by dx plus x into sin 2y is equal to x cube of cos square y. This question and the previous questions are directly not related to linear differential equation. First you have to convert this equation into linear differential equation. How you will convert? So dy by dx plus x into 2 sin y cos y is equal to x cube into cos square y. Now you divide with the entire equation with cos square y. This cos square y, total divided with cos square y. Then you will get here secant square y into dy by dx plus 2 into, when we divide with cos square y, one cos gets cancelled, that is 2 tan y into x is equal to x cube. Now you see, here is a tan y. The derivative of tan is secant square. Now you can take tan y is equal to t. Differentiate with respect to x. Now what is the derivative of tan y? Secant square y into, the derivative of y is dy by dx and the derivative of t is dt by dx. Now replace secant square y into dy by dx with dt by dx plus 2 into tan y means t into x is equal to x cube. You see, here is t and here is t. Now the remaining two terms in terms of x. Now it is a linear differential equation. Then what about integrating factor? E to the power of 2 into x dx. That is e to the power of 2 into x square by 2. So e to the power of x square, which is the integrating factor. Next step, just you multiply the integrating factor with this equation, that is e power x square into dt by dx plus 2t into x dx is equal to x cube into e power x square dx. On the left hand side is very easy, t into integrating factor. On the left hand side we have t into integrating factor. What is the integrating factor here? E to the power of x square, and here is the integration. Just we did in the previous problem, x cube into e power x square. We can write this one as e power x square into x cube can be written as x square into x. Now you take x square is equal to t. X square is equal to t k, because already we have taken that k. Better you take k. 2x dx is equal to dk. Then that is t. What is t here? Tan y. Tan y into e power x square is equal to e to the power of k. X square means k and x dx means half dk. Now by parts, first function into second function. Half into e power k into k minus 1 plus c, that is tan y into e to the power of x square, that is half into e to the power of x square into x square minus 1 plus c. This is all equal to tan y into e power x square. Now you divide this one with e power x square, that is 2 tan y is equal to x square minus 1 plus 2c into e to the power of minus x square, because we are dividing total with e power x square and multiply with 2. So that will be the solution for this differential equation. This problem and the previous problem are the same model problems. Directly they are not related to linear differential equation. And one more last problem. The last problem in the differential equation Telugu Academy textbook, that is 11th question. Solve y square plus x minus 1 by y into dy by dx is equal to 0. First you find the value of dy by dx. So xy minus 1 by y into dy by dx is equal to minus y square. Now you can write dy by dx is equal to y cube, that is y cube, by here is minus, so you can write 1 minus xy. So first you have to find dy by dx value. Whether it is linear differential equation, no, it is not directly in the form of linear differential equation. It is not homogeneous, powers are not equal, numerator and denominator. This is not non-homogeneous, this is not variable separable type. Then what we have to do? If it is not possible to do with the dy by dx, just you do with dx by dy, that is 1 minus xy by y cube, 1 minus xy by y cube, that is 1 by y cube minus x by y square, that is dx by dy plus x by y square is equal to 1 by y cube. Here is x and here is x. Remaining two terms are directly in the form of, in terms of y. So it is directly linear differential equation. And then what about the integrating factor? E to the power of 1 by y square dy, that is e to the power of minus 1 by y is the integrating factor. Now multiply the given equation with the integrating factor. You have e to the power of minus 1 by y into dx by dy plus x by y square is equal to e to the power of minus 1 by y into 1 by y cube dy, and here is also dy. Now the left hand side is very easy, x into integrating factor. Then what about that integration? E power minus 1 by y into 1 by y square into 1 by y dy. Same as the last two problems, the previous two problems. So you take minus 1 by y as k or t. There is no t, so you can write t. So its derivative is 1 by y square into dy. 1 by y square dy is equal to dt. Now this is e to the power of t, 1 by y square dy is equal to dt, 1 by y is equal to minus t dt. Minus t dt. So minus of by parts. Again the same model, e power t into t minus 1 plus c. This is all x into e power minus 1 by y. X into e power minus 1 by y is equal to e to the power of e to the power of minus 1 by y, minus 1 by y minus 1 plus c. Now we divide with e power minus y. Then what we will get here? That is minus of minus 1 minus y plus c into e to the power of 1 by y. That is xy is equal to xy plus 1 plus y is equal to c into e power 1 by y into y. So this is the solution of this differential equation. So these are some important questions in the last exercise in the differential equation. Okay. Thank you.